we discuss about the physics of 12th standard. We discuss the first chapters of your syllabus, that is rotational dynamics. So as soon as the motion is concerned, you discuss many of chapter related to the motion in 11th standard. That what we say, the particle performing the motion. As particle performing the motion, there are the different types of motions are observed. That first, particles so move from one position to the another position in straight manner, so therefore their motion is so called the linear motion. As particle get motion and vibrated about their main position up and down or through or fro, so in that case we say that their vibration is nothing but vibratory motion, that is we call oscillatory motion. As particle get move in randomly, so therefore their motion is called as Brownian motion because their random motion. So discussed by the Robert Brown. So therefore he named on his honor. So therefore their motion is so called Brownian motion. Now to discuss the rotational dynamics, we come across the some points which we are discussed in 11th standard. That points are related to the circular motion. So what is the circular motion? Then we say that the motion of particle along circumference of circle is called circular motion. Motion of particle along circumference of circle is called as circular motion. So we say that particle performing motion along circumference of a circle, so therefore it is called circular motion. It means we say that particle describing circular motion and lie on circumference. ये important बात है. Particle maintain their position on circumference and performing the motion, so that their motion is called as the circular motion. Suppose that particle performing circular motion. So what are the examples of circular motion? We say that motion of earth around the sun, motion of moon around the earth, motion of hands of a clock, motion of wheel of a cycle, motion of motor. All these are the examples of circular motion. But out of these examples, we classify that example, so therefore we discuss the different types of the circular motion. As we observed the earth performing circular motion around the sun, so it takes the same time. Motion of moon around the earth, so it takes the same time. So we say that motion of earth around the sun with a same angular speed. Motion of moon around the earth, again it takes the same angular speed. Why we say that it takes the same angular speed? Because to complete one revolution, earth takes 1 year. For each rotation of earth, it gets the 1 year. Again, motion of moon around the earth, again it takes 1 day. That is what 24 hours. Now, to discuss the circular motion, there are the two types of circular motion. One is UCM, matlab uniform circular motion. Uniform circular motion. So therefore, what is the definitions of uniform circular motion? Then we say that the motion of particle along circumference of circle with uniform angular speed is called uniform circular motion. Then motion of a particle along circumference of circle with uniform speed, uniform angular speed, so it is called uniform circular motion. So इसका मतलब ये हुआ कि जब पार्टिकल सर्कुलर मोशन परफॉर्म करता है, so इस सब एग्जाम्पल को ध्यान में रखते हुए हम ये कह सकते हैं कि कुछ एग्जाम्पल में सर्कुलर मोशन करने के लिए सेम टाइम लगता है, फॉर ईच रोटेशन इट टेक्स द सेम टाइम, और कुछ एग्जाम्पल में हम ऑब्जर्व करते हैं कि उनका जो सर्कुलर मोशन परफॉर्म करने का जो वक्त है ये डिफरेंट है. सो देयरफॉर एज द पार्टिकल टेक द सेम टाइम, सो देयरफॉर देयर मोशन इज सो कॉल्ड यूनिफॉर्म सर्कुलर मोशन. और जो पार्टिकल सेम टाइम नहीं लेता है फॉर ईच रिवॉल्यूशन, सो देयरफॉर देयर मोशन इज सो कॉल्ड नॉन यूनिफॉर्म सर्कुलर मोशन. So motion of a particle along circumference of circle with uniform speed is called UCM. अगर मैं इसको non-uniform, this is the second type of uniform circular motion, that is what non-uniform circular motion. Non-uniform circular motion. The definition comes motion of particle along circumference of circle with, बस एक शब्द इसमें ऐड कर देना है, with नॉन, ऐड करना है इसमें नॉन यूनिफॉर्म सर्कुलर मोशन. सो मोशन ऑफ पार्टिकल अलोंग सर्कमफरेंस ऑफ सर्कल विद नॉन यूनिफॉर्म एंगुलर स्पीड, सो इट इज कॉल्ड नॉन यूनिफॉर्म सर्कुलर मोशन. मींस देयर आर द टू टाइप्स ऑफ सर्कुलर मोशन, वन इज यूनिफॉर्म सर्कुलर मोशन एंड अनदर वन इज नॉन यूनिफॉर्म सर्कुलर मोशन. सो ये हो गए दो टाइप्स, सर्कुलर मोशन और सर्कुलर मोशन के दो पार्ट, दैट यूनिफॉर्म सर्कुलर मोशन एंड अनदर वन इज नॉन यूनिफॉर्म सर्कुलर मोशन. As the particle describing circular motion, it lie on circumference. If we consider the position of particle initially, it is at the position A. We join with respect to their centers. We got the radius. अब रेडियस को हम कहेंगे रेडियस वेक्टर because it has the magnitude and outward direction. So therefore that segment OA is called as the radius vector. If particle describing circular motion in anti-clockwise, so therefore particle so move from position A and reaches to the position B. So at the same time radius vector trace an angle theta and that angle theta were measured. अब ये एंगल है, इसको डिनोट करेंगे हम थीटा से और इसको मेजर करेंगे हम रेडियन. इसमें मेजर करेंगे रेडियन और इसको शॉर्ट में लिखेंगे रैड. So therefore, when particles so move from position A to position B, at the same time radius vector also rotated, and so therefore that angle so traced at the center and that angle so measured in terms of radian. Now we come across the main point and new point, that angular displacement. ये सब 11th में हो चुका है एंगुलर डिस्प्लेसमेंट, क्योंकि ये टॉपिक अगर हम पढ़ते हैं तो आपको 12th का जो टॉपिक है वो जल्दी से समझ में आ जाएगा. सो देयरफॉर एंगुलर डिस्प्लेसमेंट. सो व्हाट इज द एंगुलर डिस्प्लेसमेंट? इट इज डिनोटेड बाय व्हाट? थीटा, एंड यूनिट इज रेडियन. यूनिट मतलब इसको हम मेजर करेंगे रेडियन में और शॉर्ट में क्या लिखेंगे? रैड. एंड डायमेंशन लेस क्वांटिटी. So therefore, what is the angular displacement? When particle is moved from position A to the position B, it takes or it traces the angle theta at the center, and that trace angle theta is called angular displacement. So what the definitions comes? Angle traced by the radius vector. किसने एंगल ट्रेस किया? रेडियस. यहां था, अब यहां गया. सो एंगल ट्रेस बाय रेडियस वेक्टर एट द सेंटर ऑफ इट्स सर्कुलर मोशन इज कॉल्ड एज द एंगुलर डिस्प्लेसमेंट. सो एंगल ट्रेस बाय रेडियस वेक्टर, एंगल ट्रेस बाय रेडियस वेक्टर एट सेंटर ऑफ इट्स circular motion. Angle traced by the radius vector at the center of its circular motion is called is called angular displacement. So this is about the angular displacement. Angle S by the radius vector at the center of its circular motion is called angular displacement. Now second one is, as the displacement it comes the velocity. Now next is the angular velocity, and which is denoted by the omega, and unit as the velocity is there in displacement upon time. So therefore angular displacement upon time, and angular displacement is so measured in radian and time is measured in second. So therefore the unit of angular velocity is nothing but radian per second. Again, what is the angular velocity? The rate of change of angular displacement. Rate of change of angular displacement with respect to time is called angular velocity, omega. So what is the angular velocity? The rate of change of angular displacement with respect to time is called angular velocity. And so what? Angular velocity so denoted by the limit delta t tends to 0, delta s upon delta t, or we say ds by dt. So this is about the angular velocity, that is omega. Omega is equals to limit delta t tends to 0, delta s upon delta t is equals to ds upon dt. So this is what angular velocity. So now next topic, angular acceleration. Again, angular acceleration is denoted by alpha, and unit is radian per second square. Radian per second square. Again, what is the angular acceleration? The rate of change of angular velocity with respect to time. Rate of change of angular velocity with respect to time is called angular acceleration. The rate of change of angular velocity with respect to time is called as angular acceleration, and therefore angular acceleration is denoted by alpha. So therefore formula comes the limit delta t tends to 0, delta omega by delta t, or we say that d omega by dt, or we say that d by dt of omega. So therefore what is the omega? ds by dt, and so therefore we say that double derivative, that is d2s by dt square. So double derivative of displacement is nothing but the acceleration. The double derivative of angular displacement is called as that angular acceleration. So this is about the angular displacement, angular velocity and angular acceleration. हमेशा ध्यान में रखना. So angular displacement is denoted by what? Theta. Angular velocity is denoted by omega, and angular acceleration is denoted by alpha. So this is about the main topic. Now again we come across that the new topic is the time period, and denoted by what? T, and unit is second. So what? The time period, time taken to complete one revolution is called as the time period. Actually, as particle describing their circular motion, if it start from this position and rotate in anti-clockwise and reaches to the same point. So therefore it performing one circular motion, and time required to complete one revolution or time required to complete one circular motion is called as the time period. Again it is denoted by what? T. Again, what is about the frequency? Denoted by what? N. Because so frequency is concerned. So what about the frequency? Number of revolution taken by the particle. Number of revolution taken by the particle in unit time is called frequency, denoted by N, and their unit is hertz. So therefore we say that frequency N is equals to number of revolution in unit time. So therefore from these relations we are observed that if it takes only one revolution, so therefore for taking one revolution it takes a time period. So therefore the relation between the frequency and the time period so obtained, that relation is N is equal to 1 divided by T. So therefore we saw that the frequency is the reciprocal of time period. So therefore unit also another we are observing 1 by second. So therefore second inverse. So this is the another unit of the frequency. So what is the frequency? Number of revolution taken by the particle in unit time is called as the frequency. So therefore frequency is equals to number of revolution divided by time. If it takes only one revolution, so therefore it takes the time of time period. So therefore the relation between the frequency and the time period so obtained, and this is called frequency. N is equal to 1 divided by T. ये हो गया तुम्हारा फ्रीक्वेंसी का. So again if we observe omega, so therefore omega is nothing but angular displacement upon time. So therefore if particle describing circular motion from this position to this position, so if it completes one revolution, so therefore the angular displacement, that theta is equals to कितना एंगुलर डिस्प्लेसमेंट हो जाएगा, यहां से यहां पर आएगा, तो ये रेडियस वेक्टर गोल घूमते हुए अगेन वो वहीं पर आएगा. सो देयरफॉर देयर एंगुलर डिस्प्लेसमेंट सो टेकन दैट इज इक्वल्स टू 360 डिग्री. और 360 डिग्री को अगर हम कन्वर्ट करते हैं रेडियन में, तो पाई अपॉन 180, ये 0 gets cancelled, 18 to 2 pi. We got angular displacement of 2 pi. So therefore it revolved one revolution. So therefore their angular displacement is 2 pi. So therefore it completes one revolution. So what amount of time it should take? It takes the time of time period. So therefore omega is equal to the new relation between the angular velocity and the time period is omega is equal to 2 pi by t. Also we say that 2 pi into, इसको आप ऐसे भी लिख सकते हैं 2 pi into 1 by t. Again 2 pi ये जैसे कि वैसे लिखा है मैंने, और 1 by t के जगह अगर मैं लिखता हूँ n, so therefore again the formula comes omega is equal to 2 pi n. So ये एक रिलेशन मिला है आपको एंगुलर वेलोसिटी का. एंगुलर एक्सेलरेशन वो भी हमने देखे हैं. So omega is equals to 2 pi n and n is equals to 1 divided by t. So time period, frequency. The next topic is that periodic motion. Next topic is periodic motion. Particle revolve around the circumference of circle, so it performing circular motion. We are again come across the two topics, that was circular motion, means uniform circular motion and non-uniform circular motion. Later we discuss radius vector, angular trace, angular displacement, angular velocity, angular acceleration, and what is the time period, what is about the frequency. Now as we discuss about the circular motion, particle describing circular motion, it takes a certain time, so therefore time required to complete one revolution is called as the time period. Again it takes a revolution repeatedly. Again, the number of revolution taken by the particle is called as, in unit time, is called as the frequency. Again, the periodic motion. So, particle repeat itself. पार्टिकल क्या परफॉर्म कर रहा है? सर्कुलर मोशन परफॉर्म कर रहा है. अब जैसे गोल घूमते हुए यहाँ पर आया और उसने समवॉट टाइम लिया 1 मिनट, और दूसरा रिवॉल्यूशन कंप्लीट किया, अगेन 1 मिनट लिया, तीसरा रिवॉल्यूशन कंप्लीट किया, अगेन 1 मिनट लिया. सो नंबर ऑफ रिवॉल्यूशन, सो इट टेक्स नो प्रॉब्लम, बट इट रिपीट इटसेल्फ in after equal interval of time. So such motion is called as the periodic motion. It means particle repeat itself after equal interval of time and particle repeat itself after equal path. So therefore the particle repeatedly motion. So what is the periodic motion? It is a repeatedly motion of a particle called as the periodic motion. Called as the periodic motion. So this is the topic that we discuss in 11th standard. To discuss further concern with the rotational dynamics, say or see the next lecture. Okay, students? Thank you.